the feasibility of this kind of system. Okay, so the last part is I mentioned the network planning and the network operation. These two phases need to be traffic aware. So in the network planning phase, in fact, when we consider to how many base stations need to be deployed and where the base station should be put and how large the coverage should be, normally we put some test point, and then we have some candidate site, and we decide by solving an optimization problem, we can decide where and how large should be put a base station. But traditional way is they didn't consider the different base stations may help each other. But so taking this as an example, for example, this area I have this number of users. For a traditional way, without any collaboration, we may need to put 3 base stations, 1, 2, 3, because this user 1 cannot be served either by these 2. They have to be served by the base station 1. But if we can have these 2 base stations work together, like using comp technology, in fact, they can be served, and then this base station can be turned off or go to sleep. So that means the collaboration can help you to reduce energy consumption. So I have done some numerical results. Probably time is not enough. How much cooperative gain can be achieved as the user density increase per square meter. How many users do you have? And for each user, how many traffic are you trying to send? And number of hotspots. I mean, I'm not assuming the traffic is uniformly distributed. There may be some part is a hot spot, some part is a cooler spot. So what's this non-uniformity can to affect the cooperative gain? This is the figure, and also this is a number of candidate sites. So this is by using comp. In fact, you can also using relay. The comp is very difficult. You need to keep a synchronization, a lot of issues. But the delay is quite simple. So, but problem is that in the deployment phase or the planning phase, how many delays should I deploy, and where should I put? Should I put in the corner of 3 neighboring base stations, or in between the 2 base stations, or just in the middle of a cell? This is, in fact, a design issue. So I have done some simulation work. This is not a theoretical simulation work. We can find in the middle, in the corner, or in the inside, they have different cooperative gain, but it's not too much different. Not too much different. Probably using on the corner is the best. And for the detail for energy-aware network planning, the planning stage, you can refer to the following papers. And the last part is if you have already developed the cell, and then how to operate the network. You are not necessarily keeping all the base stations on at all the time. So we have just proposed a new idea. I call it this is a type of a self-organized network. I just call it a cell zooming. That means the cell size is not necessarily the same, the constant. They can zoom in, zoom out. Just like your camera, you can zoom in, zoom out. So if the traffic, for example, in the middle cell getting heavy loaded, and then the cell size may shrink, may getting small. And then if the user move to other cells, you can coverage, you can enlarge. So this is zooming. Or if the central cell have in the nighttime have very light traffic load, you can turn it off, and then the remaining user can be served by the neighboring cell in a collaborative way. This is the concept of cell zooming. And we also done some have done the simulation work. This is the 100 cell. These cell sizes are all the same, but the traffic are non-uniformly distributed. This is a hot spot. This is a cooler spot. And we can find that we can have there is a trade-off between the energy saving and the quality of service. So because the cell zooming, so that means sometime when you have a service request, you may not be accepted because the traffic, the resource is not enough. So in order to avoid that problem, we have set a ratio. That's we reserve some part of resources for this kind, so that increase the quality of service. That means as the ratio going up, the service quality is going up, but the energy consumption is also going up. This is outage probability is going down. So this showing how outage probability, the relation between outage probability and the normalized energy consumption. Normalized means 100% means all the base station are switch keep on all the time. There are no zooming, no switch off. Compared with that, we can have a very good energy saving. So this 2 point, I cannot see. This 2 point is a static case. Static case is without zooming, they cannot guarantee the quality of service. The quality of service is very, very bad, although you can save energy. But the problem is that you want to switching off this base cell so that this cell can zooming out. But the problem is the zooming capability may not be enough. And then you cannot switching this off. But what will happen? And then, in fact, you can deploy a smaller cell, probably smaller but more cell. That means on the daytime, you are consuming more power, but at nighttime, you can switch all this off. This is a very simple model. But only keep this 5 or 6 on. And then you can, in nighttime, you can save more energy. So totally, you can save energy. This is the recent work. Will be published in soon. So in summary, this is I'm trying to say we need in the future, both in the network planning phase and the operation phase, we need to consider the traffic in more details. And we need to introduce a more collaboration scheme among the base station, among the different networks. So in the future, I think we need to have coverage on demand and also service also on demand and the resources on demand. So I conclude my talk. Thank you so much. All the papers you can download from this website. Thank you so much.
Okay. Thanks, Dr. Niu. Do we have some questions?
So with your zooming technique, are you doing that through power control or through antenna downfill?
In fact, I'm not still going too much detail about how to implement this type of things. But in the simulation model or the analytic, we are just simply to increase the power. Yeah. So the people argue to me that if you increase the power, your antenna may, the angle or that it may not be optimal. That's true. But I think this majorly happens in the lower traffic, a very low period. At that time, in fact, the optimization is not an issue. So the resource should be enough.